Hey guys, this video is going to be over the page of notes that you will find in the bucket, the math bucket. It is a pink bucket. It says pre-algebra on it. These are the notes that you will need. You're going to glue these in your journal when we're done with them. It is a practice over slope and y-intercept, and after you're done with these notes, you'll have another video for another set of notes. Okay, I'm sorry I had to be absent today. It was not expected, so this is technically what we would have done in class anyways. So we have to get this done so we can move forward tomorrow. So first of all, when we find the slope of anything, we always use the little saying, rise over run. Now, whenever you talk about rise over run in a graph like this, or this, you count how much you go up and how much you go over. And the same thing is technically happening here, but we can't see how much we're going up and over. We're gonna actually have to calculate. So remember that this side is the rise and this side is the run. So let's figure out how much we are rising from 4 to 6. If you need a little bit of help calculator-wise, you will do 6 minus 4, and that is going up by 2. The run for this is from 0 to 3, which is 3. So our slope, rise over run, is 2 over 3. Our y-intercept is always where x is 0. So here is x is 0. The number that it's paired up with is 4. Which means that our y-intercept is 4. Remember that a y-intercept found on a graph is where the line that they give you crosses the the y-axis. That's why it's called a y-intercept. It's where the graph crosses the y-axis. Here is where the graph crosses the y-axis, and it is at number 3. So that's how I write my y-intercept. Now let's talk about slope of a graph. Remember that slope is still rise over run. If I know that my graph crosses right through there at 3, and it looks like it crosses right through there at 4, the lines technically don't actually have to help me on this one. I don't even need them because I see the numbers and I can count the numbers. I go down 1, 2, 3, down 3, over 1, 2, 3, 4. I use the little tick marks along my axes to help me count. So my rise was -3 because technically we go down and over. And my run is, my run is 4. So that's my slope and my y-intercept. Remember, if a line is going down, and we always read a graph from left to right. If the line is going down, it's a negative slope. We have to go down, then over on negative slopes. All right, let's talk about an equation. You might remember an equation that looks like this from back when we used to talk about unit rate, proportional graphs, and stuff like that. That number right here was the rate. It is the same thing as a slope, because remember, slope and rate of change mean the same thing. So for slope on this one, I'm going to put -2 over 3, which means that this extra number out here to the side is going to be my y-intercept. It's kind of like my starting point. We talked about this a long time ago, but just a refresher, that is a -6 as my y-intercept. All right, let's look at this graph here. Again, this graph is going to be a little bit hard to read number-wise because the lines didn't print out very well, so sorry about that. We have to make our own dots as well because there aren't any perfect little dots. If you can find another perfect dot somewhere along this line, go for it. I see one right there. It's at 5, -1, where those lines meet each other. So let's just use these. So first of all, I'm going to go and I'm going to find my rise over my run. I'm going to go up enough times, 1, 2, 3, to go straight across to that dot right here. So my rise was 3. My run is 1, 2, 3, 4, 5, 6. And remember that we're trying to make those perfect little stair-step triangle patterns. Rise and then run. And I could not really see my lines, but these numbers above really helped me to figure out where the lines would have been. So my rise was 3, my run was 6, and technically this reduces down to 1/2. The other ones that I had, the other slopes, if I type them in the calculator, these are the reduced versions. Sometimes it's a little hard to tell which ones reduce and which ones don't, so I would just go ahead and type all of them into the calculator just to make sure that I know that they don't reduce, but this one actually does. So remember, the reduced version is the actual answer. Okay, so this y-intercept would have been way down here where the graph crossed the y-axis. which should have been, I can't remember, read that number anymore because I wrote over it, 1, 2, 3, 4. So -4. And again, we have an equation. This number here would have been my rate of change, which is my slope, same thing as my slope. And this extra number over here is the same one over there, okay. My y-intercept is -6. If it would have said +6, that would have just been a +6. But since it says -6, it's a -6 as my y-intercept. All right, let's look at this table. We haven't had a table in a while. So I remember that my rise is on this side. I'm going to scoot it over here so I can write better. And my run is over here. And I'm dealing with negatives now, so remember that your calculator might help you on this. From -5 to -7, I'm trying to figure out how much it's going. And these numbers are actually going down. I can tell because the negatives are getting bigger and bigger, which tells me that my numbers are going down. So I'm going down by 2. And if you needed to type this in your calculator, you would have typed -7 minus -5. You would have gotten -2. So -2 is my rise. My run is -2 to 0, which looks like it goes up by 2. Now you'll notice that these don't create a perfect pattern. But if we tried any of the spots, I'll show you in just a second what will happen. So if the rise is 2, the run is 2, that does reduce also down to -1. If you type this in the calculator, your answer will be -1. And like I said, remember how I said we don't see a perfect pattern because that was going 2, that was going 3, that was going 1. Technically, our tables don't have to go in a perfect pattern. I said that one was running 1 and that one was rising a -1. So even if I were using the bottom 2 dots, I would have a -1 over 1, which is still -1. It's the same slope that I had originally. Okay, doesn't matter. As long as these points fall on the same line, you will be having the same slope. Okay, y-intercept, remember, is always where x equals 0. That one right there. It is the number that it is paired with, which is -7. That is just like if it was a coordinate on the graph. Okay, that's how we get that number there. All right, let's look at these graphs. We have a few more graphs, examples, because it'll help us really get better at slope. So slope is rise over run. And luckily this time they gave us some dots. The lines are hard to read, but they're barely visible, and you can kind of tell by the size of the squares where to go. So first of all, we're going to go down. 1, 2, 3, 4, because I had to get in a perfect position to slide right on over to that dot right there. So I went down 4, over. This one's going to be a little bit harder. 1, 2, 3, 4, 5. That's why we're doing it together, remember? All right, so the rise is -4, the run is 5. This, and if you type it in the calculator, it does not reduce down to anything else. So that's your answer for that. Your y-intercept would be here, and they don't give you the number, so you're gonna have to count. 1, 2, 3. So the y-intercept fell along the y-axis at 3. All right, on this one, the y-intercept is along the y-axis right there at 4. I do notice something about my numbers here. They're counting up by 2, so I'm gonna have to be very careful when I'm doing my my rise over my run. Again, they don't give you dots, but I found some perfect dots even without the lines that they gave me. Looks like it goes up this much and this much. Now, you would say it goes up 2, right? Because we went up 2 boxes. However, 2 tick marks, whatever. However, these are counting by 2, so 2, 4. We actually went up 4. And when we go over, it seems like we're only going to go over 1 little box. But again, these are counting by 2, so we're going over by 2. So we technically have 4 over 2 as our rise and our run. 4 divided by 2 does give us 2, so our slope is 2. Interesting. All right, let's move over to the next one. This one has lines and numbers that we can see, thank goodness. Here is a perfect coordinate here, and I see one also down here at -2, which I noticed that dot right there is my y-intercept, so I'm going to go ahead and write the y-intercept in. All right, and then let's find the slope. So I'm going to go up and over to get my slope. I go up 1, 2, 3, 4, over 1, 2, 3. So up 4 over 3. My rise is 4. My run is 3. All right. that's the video for that.